Okay, good afternoon. So this is a continuation to the discussion that we have in horizontal data control network, which is on triangulation. So last time we discussed the computation on the intervisibility of station, and we also discussed the reduction to sea level. So this time I'm going to present to you another type of computation in which we are can apply to our designing of our control network and establishment of our control. So we have here reduction to center. So this reduction to center is applicable if it's impossible to establish a tower, like for example, para maging intervisible on one station to another. And then if it's time consuming na, what if a certain point is talagang nakadesign na siya na doon siya ilagay but it's impossible to occupy the point. And then pag nag-establish pa ng tower, time consuming na, and then it would and expenses pa, so it would waste another budget and money of the project. So one of the alternative for the establishment of towers para lang makita mo ang mga station nga which is unavailable or hindi talaga intervisible is this one, the reduction to center. So the concept of reduction to center is just you have to establish another point in which makikita mo na ang ibang point with respect to the original point. So bagang magbubutang ka lang observation point. Okay, so this is an alternative to tower or building in establishing intervisibility of station. So where another station, so we call it eccentric station that is adjacent to a true station. So more or less, much better kung hindi sobra kaharayo natin ginhing mga eccentric station ha aton true station. So most of the time, less than 5 meters or less than 7 meters will do as long as safe na hiya sa ground. So kung impossible talaga ma-occupy ang true station, then you can do an eccentric station. So the distance between the eccentric station and the true stations are measured. You can measure that one. And then the angle at the eccentric station between the true station can be observed. So since it's impossible to establish or to set up the instrument at your true station, then you can do that while you establish a centric station. So this centric station, it can form a triangle na pwede mo, you can compute the angle and the distance para ma-determine mismo ang angle na gusto natin ma-determine with our true station. So I have here a scenario in which we are going to establish eccentric station and how are we going to do it. But it doesn't follow all the same formula. We do not follow the same formula, this one. As long as the concept on how the eccentric station is being established and paano mo siya ma-compute, then that is only the coverage of this topic. Okay, so like for example, we have here a scenario. So let's say this true station is the true station. Like for example, ito yung corner or baseline or yung corner mismo ng iyong triangulation. However, one of the station is impossible to be observed. Like for example, this is your baseline or this is the length or distance between your points. And then you have here obstruction like a buildings, and it's impossible naman to establish towers in opposite station, or it would be time consuming to establish the towers. Then what we are going to do is you can establish this one. This is called now the eccentric station. So the eccentric station, it depends upon which station you are going to eccentric for. Like for example, this is the true station, so it should be adjacent. So this one is adjacent to our So kung like for example, gusto mo niya makita nga din pero may obstruction, then pwede ka mag-establish another point. So this is now our eccentric station. So from the eccentric station, we can determine the distance. Pwede natin ma-measure ang distance from that point. And then we can measure also the distance from eccentric stations to here. And then we can observe the angle between here. So if our goal is determine the distance from here to here, then you can employ trigonometric formulas or computation to determine the distance between stations. So for the angle, same as the distance, you can compute the distance from here, then the distance here using sine law or cosine law. Okay. So in the same manner, like for example, we have the baseline, and then this is, for example, this is another true. Again, this is another true station, but during the reconnaissance, baka na-neglect, like for example, na-neglect yung safety ng ground, hindi pala siya pwedeng lagyan ng instrument or hindi siya pwedeng ma-set up pa ng instrument or like, for example, in that kind of situation. So what you're going to do, if it's impossible for you to observe here or to set up your instrument here, then you can select or you can establish a eccentric station. So for the eccentric station, it should be again nearest to your true station para hindi rin dako ang changes sa inyong mahihimo nga angle. And then you measure the distance from the true to your eccentric para ma-complete ang imong triangle to compute your data. And then you need to observe, so this is your, like for example, this is your eccentric station. So you can either determine the distance here. So since adding an instrument, you can determine the distance here. Then pwede mo yung ma-determine distance here. Since you cannot determine the distance, diba? Dili mo yung ma-determine kahit dili mo yung ma-observe. And you cannot also determine the distance here because it's impossible for you to set up the instrument. So what other data that you can get? So you can get the angles from the eccentric station. So from the eccentric station, either you can compute the angle here, then you can measure this angle. So you can measure the angle, and also you can measure this angle. So if you have the angle here and you have the distance, you can use sine law to compute the, our goal here is to compute the, like for example, this is a corner of your designed network. And di rin man kita makakita nga, di rin natin niya mako-compute or di rin natin niya ma-observe. Pwede natin niya i-compute, but we cannot observe this one since it's impossible to establish our points here. So what we are going to do, we measure the distance here, we measure the distance here, and we measure the angle in between. So if we already have two distances and in one angle, what can we get? We can solve the distance by sine law, and we can get the angle here by applying either cosine law or sine law. So, pag meron ka ng this angle dito, we have the angle here, you just have these two angles, and then you can get na the inferior angle of your designed network. Okay, so I have here an example. So in measuring the angles at a triangulation station C, so let's have here, meron tayong station C. So it was necessary to set the instrument over another point P. So bangin impossible natin ibutangan natin instrument at point C. So that's why mag-select kita point P. So at a distance 5.61 meters from C. So on our distance from eccentric to our true station is 5.61 meters. So the angle measured at P, so yung angle measured at P from C to A was 131. So the angle station B was measured to 85, 2514. So the distance, may measurement siya ng distance. Distance AC is 638.4.40 and BC is 728.585 meters. So you are going to determine the interior angle of your design, which is angle ACB, length of AP. This is the length of your true station A to the eccentric station, and the length of your true station P to your eccentric station. So let's have an illustration. So for the illustration here, we have, let's say this is your C, and mag-establish kita ng point P. So let's measure 5.61 meters from point C. And let's say we have here our point P. Okay, next. So we have here given 131 degrees, 12 minutes, and 08 seconds. This is the angle na na-measure at point P. Pag-observe na yan ng C2A. So our A, so mag-measure lang kitang 131 degrees nila para maabot kita natin point A. So let's say that is 131. Again, this is 131 degrees, 12 minutes, and 8 seconds. And then the distance of A to C, let's say this is A. So let's say this is A. So the distance from C to A, given naman, which is equivalent to 6384.40 meters. Okay, so what's next? We have another given, the angle here. So we have angle B. Meron tayong another station, which is P. So given naman yung ating horizontal angle, which is 85 degrees, 25 minutes, and 14 seconds. So this is the measurement from C, P, and B. So this angle here, you measure 85 degrees from C, then you turn the instrument up to 85 degrees, 25 minutes, and 14 seconds. Then you can find point P somewhere along in this line. So let's measure 85 degrees here. So let's say that's 85 degrees, and then that is 85 degrees, 25 minutes, and 14 seconds. And this is now, so along here is the location of your point P. But we have a given of 7,258.85 meters. So this is the distance if here. So we are going to measure from C, 7,585 hanggang doon, mag-intersect siya sa line ng point B. So let's say this is now the location of our point B. So here is 7,258.85 meters. And this is now our point B. So since it's impossible for us to determine the angle here because dili kita maka-establish ng instrument ha point C, then ang aton lang ma-observe is ini lang nga data. So our goal is to determine how much is this one. So pira inihiya nga pugos. So number one is we are going to determine the angle A, C, D. So this angle here, this interior angle of your network design. So how are we going to do that? So we can solve that by, we can apply cosine law or sine law because we already have distance here. So we already know the distance from our eccentric station to our true station. So this is 5.61 meters. If this is 5.61 meters, then we have another distance which is 6384.40, right? And then we have the angle. We can solve this one, right? We can solve this one by sine law. If we have this angle here, we already have angle here, then we can compute our angle here by just taking the difference of 180 minus this one. The answer would be the length of the angle here. Same is true if we consider this another triangle. If we can measure this one and then we can compute this angle here. If we already have the angle, then 180 minus this angle and minus this angle, then we can compute the interior angle of angle C. So by that, we can compute now the whole interior angle of your network A, C, and B. Okay, so let's try this one. So let's focus muna on this side of the triangle. So our aim is to look for the value of this angle here, right? So if we consider, so that let's say that is theta. So mag-assign kita ng mga letter Greek letters para dili kita ma-confuse. Let's say that is theta here, and we have, let's say this is phi. So if angle, this whole angle is just the sum of our theta and our phi. But we don't have the value of theta and we don't have the value of phi. So that is our main objective now, to solve for the each. So we want to solve the theta and we want to solve the phi. Okay, so this is alpha. Let's say this is alpha and this is gamma. So to solve for angle ACB, so we have here angle A, C, this have A, C, and B. To solve this whole angle here, we need to add theta and phi. Okay, so to solve for phi, let's start with phi here. So we are going to consider this triangle A, C, P. So ito munang sa left side na triangle. So draw. So by sine law, so since we already have distance here and we have the distance 5.61, we have the alpha, we can employ, and this angle here, di ba na may measures at the eccentric station. So pwede natin gamitin yung sine law since meron tayong distance. Opposite ito is this one. Then meron tayong isang distance. Then opposite to is this one. Then we can get alpha. So if we can get alpha, you add it with this one, 131, and then you subtract 180, the result will be theta, right? So let's try this one. So this one, sine law, the distance over the opposite angle, which is sine 131, 1208, is equivalent to ratio of distance over alpha. So 5.61 over sine alpha. You cross multiply this one, you get alpha. Okay, sine alpha is equals to, then evaluate. Then you check if my solution is correct. Then you get alpha, which is equivalent to 0 degrees, 2 minutes, and 16.37 seconds. So if you get this value, you need to add this one with 131. So this is 2 minutes, this is 131, minus 180, the answer would be our theta. So our theta is equivalent to 48 degrees, 45 minutes, and 35.63 seconds. So just check if the computation is correct. But I guess this one is already correct. So double check lang. Okay, so we are done with finding the theta. So next we need to find the value of our phi. So if we get our phi, we need to add this with our theta, then we get our desired angle ACB. Okay, so next we have here, our goal is to compute for phi. So to compute for phi, the same lang din yung value. Since meron tayo ditong distance, and then opposite ng distance is the angle, since given to, which is sine 85, 25, 14, then we can do that. And then they have the distance 5.61. Yung opposite na this line nito is yung angle gamma. So this one is gamma. So 5.61 over gamma. So you just cross multiply, then you can get the value of gamma. So gamma would be, just evaluate this one. Gamma would be 0 degrees, 1 minute, and 34.1 seconds. So our goal is to compute for phi. So how are we going to get this? Just add our gamma, which is 1 minute 34 seconds, to this 85 degrees. Tapos minus 180. Since triangle to, minus 180, you can get the value of our phi. So our phi now is equivalent to 36 degrees, 35 minutes, and 46.9 seconds. Now the question, can we get now the value of angle ACB? So the answer is yes. Since we already have theta, we already have phi, then you just add. So you just add the two values here, the theta and the phi. Now the result will be, so the result will be equivalent to 48, 45, 35, and 63 plus 36, 35, 46.9. Then the answer would be 85 degrees, 21 minutes, and 22.53 seconds. So this is the answer of our question number 1. So number 2, we are required to compute the distance of AP and the distance of PB. So there's no problem with that since we already have the angle. We have the measurement here, we have the angle here, we already completed the angles of the triangle, so we just employ sine law to determine the side of to determine the length of AP. Okay? So to solve for AP, you can use sine law, diba? You can use AP over, yung opposite ng AP is theta. Since meron na tayong theta na solve kanina, which is this one. So, meron na tayong theta. Tapos, opposite lang. You can use this one, this relationship. Itong distance na to over sa angle, opposite angle niya. Then, cross multiply. Substitute niya yung theta, the value of theta, this and na-solve natin kanina, which is 48, 45, 35. And then our AP would be equivalent to 6380.70 meters. Okay, next to that, we are going to compute now our distance PB. So for the PB, same lang din yung process since we already have the angle theta. So opposite to that is our line PB, when we can employ sine law. Then we have here the distance here. And then opposite to that is this angle. So we can compute na the value of our PB. So to solve our PB, so sine law, PB over sine Phi. So you substitute the value of Phi, di ba? Phi, ano compute natin sa number 1, which is 36, 35, 49, 46.9. We substitute this one, then cross multiply, we got PB. So PB now is equivalent to 6254.346 meters. Okay. So do you have any questions? So there is no certain formula on how are you going to compute if you use reduction to center. So you just employ trigonometry and basic knowledge on the azimuth, the bearing, and the angles, the relationship between angles. Okay, so next to that, we are going to discuss the last computation, which is, I guess, on spherical excess. So see you on the next video.